I'm just going to hit record. So you should be working your way through the Mobius tutorials. And then, of course, there is Maple. So let me just show you. I've got a Maple window open. Let me just share that with you. So Maple is pretty important because you're going to use these kinds of commands in your lab tests and in the final exam. So I want to try to teach you a little bit of Maple as well. So Maple's the program and Mobius is the platform. Okay, so there's some of the things that we can go through together today. I think I might just start off just solving a problem, and I'm just going to feel free to list your questions in the chat. Okay, and if you want to say something, just say something, right? If I've made a mistake or if I've written something that's not clear, just feel free to unmute yourself and say hi, because this is how you actually get the conversation going. So yeah, just go for it. So let me start, and we can then just see how we go. Okay, so all right, so let's do a classic one. I'll just share my PDF with you. Sometimes it takes a while to share. I thought we could do this one here, okay? And so the first few questions are about solving inequalities and solving sets. So this is a classic kind of problem. So let's work through it and see how we go, okay? All right, so I'm going to shift over to my document camera and we can solve it together. All right, so this is question 4, part E. So we want to solve for x, okay? And we've got, where is it? Yes. We want to find x is greater than 6 on x minus 1. And so the first thing we would see regarding this one, Hong, the questions are in the course pack on Moodle. So maybe someone can post the link to the Moodle, the PDF in Moodle. That would be great if someone could help Hong out and post that in the chat. Okay, but I will just write out the questions anyway. All right. Leon, thank you. I think that's it. Okay, you should be able to go there and find the PDF. Okay. All right, so this is what we're solving for. Okay, so let's firstly recognize that obviously x, whatever we solve for, x equals 1 cannot be part of the solution because it's not defined, right? Okay, so who can give me a strategy for this kind of problem? What's something we could do, some sort of algebraic move or something? Who can tell me in the chat what we kind of have to manage away that x minus 1? Can anyone suggest anything in the chat? One rule is a good question. We really want to get rid of that. We could multiply both sides by x minus 1. And we're going to multiply by x minus 1 all squared, which is positive. Okay. Yeah, that's great. Thanks, Theo. One rule, we're going to do it graphically as well. That's another great suggestion. We'll do that in a minute. Okay, so this is positive. If I multiply that side and that side by something that's positive, then I keep the same inequality. So let's call that star. Okay, and so what we can do, we can cross that off with that, and then we've got the cancellation we wanted, and all we need to do is rearrange. Okay, so let's take this to the other side. Oops. So I'm going to take this to the other side, and it will be that. That's so our problem is now transformed, right? So we started with this problem, with this condition, and now we're in this space. Now it's tempting to expand the brackets, but you've got a common factor, which is always great. So we're going to factorize. Okay, so we've got x minus 1 times x minus 1, this, and I'm going to simplify that square bracket. Okay. Okay, now I can factorize that. The factors are going to be -3 and -2. Sorry, -3 and +2. And so, yeah, thanks, Maximilian. You're right. I said the wrong thing there. And so this is a quadratic, and it's going to cross the axes at +3, +1, and -2. Okay. And so it's going to look something like this. Something like that. And so the question now is, well, what x points make sure the graph is above the x-axis, or above or on the x-axis? Okay, so you can see it's going to be here and here. Now remember, we're excluding x equals 1, so we can't do that. Okay, so the solution will be x between -2 and 1, or x greater than 3. Okay. You can do it separately if you want, no problem. You can do this problem a few different ways. Okay, so you can definitely do it. If you want to split it up into cases or different parts, that's not a problem at all. Yeah, you can do that. So I would just suggest that you choose the ideas and the methods that suit you the best. Okay. Yeah, Keith, that's fine. Yeah, so if this is the interval notation, you can also write it as, you could say the solution set is those real numbers such that x is between -2 and +1, or x is greater than or equal to 3. So that's fine, Keith. Okay, so the basic strategy then for these kind of problems, you've got some division and you want to get rid of it. You want to manage it away. You could multiply by x minus 1, but then you don't know which way this inequality is pointing. So if you multiply by something positive, you can get your cancellation and still work it out. Drawing a picture is usually useful. Okay, so let me show you something else now, which I think you'll be pretty impressed with. This is maple. And guess what? Maple can solve inequalities. It can solve inequalities. So here I've got the solve command. Okay, and maple's not perfect, but if I want to solve this inequality here, I can do that with respect to x, and kaboom! Yes. Okay. So there you go. It realizes that obviously x can't be 1, and it gives you the two intervals. Okay. So if you're stuck, remember you can use maple in, for example, the final exam or in lab test 2. You'll be able to use maple. So it's always handy to know that, well, if you can't do it by hand or if you want to check it, you can always use maple. So maple is a pretty clever thing. And I agree with you, sometimes it's not easy to find all the roots for a cubic equation. Okay, this problem just managed to work out nicely, but maple can find the roots. Okay, maple can find the roots. So that's a really simple type of problem, but the method is usually the same for these kinds of problems. You're trying to simplify, draw a graph, and then solve. Okay. All right, let's do something a bit more fun. Okay. I'm going to put the PDF back up. And I wanted to look at number 7. Okay, so these are quite fun questions because they're asking you whether they're true or false. And if it's true, then I guess you probably should know why it's true, or you should have some understanding of how to justify it. And if it's false, then the idea is to give some sort of counterexample or an example where it doesn't work. Okay, so let's have a look at the first one. Okay, so if A is greater than B, then 1 on A is less than 1 on B. So is that a true statement? And if it's not true, can anyone think of an example where it doesn't work?
I think it's true.
Is that you, Denzel?
No, it's me, Aaron.
Aaron, hello.
Hi.
So why do you think it's true? Thank you for jumping in.
You know how 3 is bigger than 2, but there's more in 1/2 than there is in 1/3. Oh, I don't think that you can hear me. Just give me a sec.
No, I can hear you. I can hear you fine. So for that example, it definitely works, right? So if A and B are positive, I think it works, right? So what happens if one of them was negative? Would it still work? Let's say B was negative. Yeah, so I think it works for some things, but not everything. Okay, so Aaron, you're right. I think it's true for A and B positive, where A is bigger than B, but when you get into the negative values, it's not true. So I would say that that's definitely false. Okay, it's false because it doesn't hold for all numbers A and B. Yeah, and you can modify it, Maximilian. You're right. You can modify it and get it to work. Okay. What about part B? If A is less than B, then the square is less than the square of B. Is that true or false? Okay, so Snea says false. Theo says false. Maximilian says true. Du says false. Okay, so can anyone think of a counterexample? Snea said, yeah, -9 is less than -5, but the squares are different. Okay. Anyway, what about part C? Is part C correct? Is it true? Sorry. Yeah, it's definitely true. Okay. And I think the reason is, and I'll put this in the chat, it's an increasing function by x greater than 0. So, you know, that's let me see if I can just draw something quickly. Okay, so if I've got my axes here, and this is like my x squared function. So if I'm just here where we're in the positive values of x, and that's A, and that's B, of course, B is going to be above A, right? So in terms of height. But if I'm over this side, it's a different story. Okay, so you can kind of see from the graph why C, part C, is true. Okay. All right. This is fun. Let's do another one. Let's do part D. Here it comes. If A squared plus B squared equals 0, then A and B are both 0. Is that true? Is that false? If you have the sum of two squares and they add up to 0, are both of the terms A and B 0? I think people are saying it's true. Sneh has done a bit of justifying as well. So, yep, it is true. It's absolutely true. Okay. What about the last one? If A is bigger than -1 but less than B, then A squared is less than B squared. Okay, can you find a counterexample? Oh, imaginary, yeah, that's right, Aaron. Imaginary number. We're excluding imaginary numbers from calculus here. I know you see them in the algebra part. Yeah, yeah. Snaya's got a counterexample there. So E is false. E is false. Okay. So let me show you something cool with these functions. I'm going to show you in Maple the plot command. So you might have already seen this, but let me just show you anyway. So let's say I wanted to plot the graph of x squared. Make it a bit bigger. Okay. And let's plot it for x equals, I don't know, -5 to +5. Okay. So the plot command is super helpful because you can basically get graphs, very complicated graphs, in Maple very, very easily. And one thing you'll notice is that having the power to draw these graphs, whether it's in Maple or GeoGebra or you know, whatever platform you're using, can really help you understand things. So I've drawn a few graphs here. So here I've drawn sine x minus cosine x to look for the zeros. Here I've drawn tan x and 1 just to put them on the same graph. You've got the square brackets there. So 2 graphs on the one curve. And here's a really basic one. So plot command is one of the simplest things you can put in. And yeah, it's really great because you can quickly and easily see what a function looks like. Up here, I've used another command called the smart plot, which is just it's just a way of plotting relations rather than functions. Okay, so you probably haven't used Maple yet, but by the end of this term, you'll have used Maple a lot, especially in the second half of the term. So don't be scared about Maple. Has anyone used Maple before? Let me know in the chat if you've used it before, because it's new to many people, but it's super powerful. It's not always perfect, and you've got to type in the commands. Okay, so I mean, I really like GeoGebra and those because it's pretty intuitive. It takes a bit more time to learn Maple. Okay. All right. Okay, so let's go back here. All right. So let's say I won't do this one, but I'll just show you quickly how you can do it in Maple. Okay. So can you see question 9 there? Prove that 1 plus x squared is positive for all real numbers. By considering cases or otherwise, prove that that is always positive. So what you could do is just plot those 2 graphs in Maple, right? And just have a look at them. You're not really proving things there, but you're definitely confirming what's going on. Okay. Oh, Eddie, that's a good question. Yeah, I'll get to your question in a second, Eddie. That's a really good question. So let's talk about that in a second. So the Maple, Maple is used within Mobius. Okay, it's a bit weird, but what I'm doing here is I've got a standalone window that I've used. This is I put the link up. Hang on, let me just have a look. This is the link to go and get Maple. So, all right, and so you log on and you click on Maple, and you need a VPN and stuff. Okay, so that's the access. You definitely need to get access because lab test 2 you'll need it. Final exam you'll need it. Okay, so you've got Maple in one window and you've got other stuff like Mobius or something else in the background. Okay, yeah, if you do Mobius will help you learn Maple, and there are extra like documents, Sneha. Okay, so Eddie, let's talk about how to simplify this thing. All right, that's another one. Okay, so Eddie, has this got to do with this week's Mobius quiz, right? Am I right, Eddie? It's the Mobius quiz, right? I think I'm right. So let me show you how to simplify that in Maple. Yeah, I think it's question 6. So let me just go down here and I'll show you how to do this. Okay, so I'll just share my Maple again. All right, so just before I do that, I'll go over here. Yeah. So just before I go over that, if I wanted to plot 1 plus x squared x cubed. Okay, that's it. You can see, well, always going to stay above the axes. Okay. So, Eddie, you wanted to simplify this, right? So let me show you how to do it in Maple. So I'm going to define an expression to be the sum of, now what was it? It was 50 over 2 to the I, right? So this is basically a geometric sum. And you sum the I from 0 to n minus 1. I think that's how you do it. Okay. So what I'm doing there, Eddie, is I'm telling Maple that I'm defining a new thing called P. That's what this funny equal sign means. And that P is the sum of the first n terms of this thing here. Okay. So if I press return on that, let's see what happens. So Maple's not only understood that I've defined this new thing P, but it's simplified it. Okay. So Eddie, in regards to your question, this is basically a geometric sum. You can do it by hand, but Maple is a bit faster. And that should be the missing piece for your Mobius thing. Is that making sense, Eddie? Let me know in the chat. Cool. So there you go. You can also do it by hand if you like. Okay. So I think the next step is to take the limit as n goes to infinity, something like that. And of course, you know what's going to happen there, right? Okay. All right. So what else have we got? Let's do some composition of functions. At the end of the first lecture, I did some functions of functions. So let's see if we can move through those. And yeah, then we can do some more graphing and stuff like that. Okay. And if you want me to do specific stuff, just let me know in the chat. Okay. All right. So let's go here. Yeah. So I think 11 is a good question. It's designed to sort of test you on how well you can combine two functions, right? So you've got a linear function and a quadratic. What are all the different sort of combinations of these functions? So I'm going to do part B first, and then I'll do part A, and that'll give us what we want. Okay. All right, so I'll just go back to my document camera. Sorry, I know it's a bit clunky with all the sharing and stuff, so I try to be as fast as I can. All right, so we've got f of x is x plus 5, and g of x is x squared minus 3. Okay, so what is the following combination? G of f of x. Okay, so it's gof x. Okay, so that means G is acting on f of x. That's how I usually think of it. Okay, so instead of g of x, you've got g of f of x. So you apply that. All right, Aaron's in the house. Let's see if your prediction is correct in the chat. All right, so it's g of x plus 5. So instead of putting in x here, you put in x plus 5. All right, yeah, cross fingers. Okay, and so we now replace that with x plus 5. Okay, so let's expand. And you're going to get 25 minus 3, which is 22. Nice. All right. So what then is GOF 0? GOF 0 will be 22. Thank you, Aaron. Okay, let's switch the order around. So instead of GOF, we've got FOG, f of g of x. Okay. Okay, let's see. So that's our f. We're going to put x squared minus 3. So that goes in there and that. Okay. So x squared plus 2. So you can see these two things are not the same. Okay, so the order matters. So GOF and FOG are not usually the same. So the last thing they want us to do is to calculate FOG of 2. That's going to be 6. Yes. Great. Okay, cool. So that's a little bit about combining functions. We'll see these kind of combined functions when we do things in this course, when we do things like the inverse function theorem. So basically you're differentiating inverse functions and stuff like that. And also there's, of course, the chain rule for derivatives. You know, you're differentiating a function of a function and stuff like that. All right, Snare on the chat. Random question. Why don't we keep the closed brackets? Yeah. So this is a really good question, and I'm glad you asked, Snare. Okay, so this is the real number line. Okay, and so we can write it like this, or like this, or like this. Okay, they're all okay. That's fine. We don't include infinity. Okay, infinity is not a number, as you say, Snare. It's not a number. Okay, it's a concept, it's an idea, but it's not a number. We can do some things with infinity, but it's definitely not a number. Okay, and in today's lecture, we talked about indeterminate forms, right? So you know that 2 minus 2 equals 0. But when you have something like this, you don't really know. Okay, so we never include infinity as part of the real number line. Now, you can talk about the extended real number line, but we won't do that in this course. Okay, it's like maybe wait until like a bit more advanced maths for that. So don't worry about it. Okay, cool. That's a great question. Okay, so let me go back to, yeah, I might go back to Maple, and I'll show you something pretty cool here in a second. Yep, let me just get this going. Yeah, okay. So let me share. All right, so this is a really interesting question here. Use a graphical approach to solve this thing. Now you can do it algebraically, of course, but the thing that's a bit annoying is the absolute value signs. So let me show you how you can explore this with Maple if you want to, or you can do it with another program. I think I did one of these earlier today, so let me see if I can pull that out. Okay, here we go. Let's see, is this the right one? Nope, this one. Yeah, okay. So you can see here, what I've done is, instead of using the solve command, I've used the plot command. Okay, and this is just the code for the absolute value of 2 times x minus 5. And here I've got some square brackets. I've sort of got what's called a list here, and I've got basically two functions, and I want to plot them on the same set of axes. Okay, so they're separated by a comma, and they're going to be plotted on the same set of axes. Okay, and so I do that, boom, you can see there's one intersection here, there's another intersection here, and so there's two solutions to this problem. And I can even go a bit further and do the solve command, and Maple finds both of the solutions. So x equals 1 and x equals 7. Now, it's probably easier just to draw a picture, right, with pen and paper or pencil or something, or go to GeoGebra and do it. But what I'm trying to show here is just some basic moves with Maple. Okay, so at the moment we've looked at the plot command and the solve command. You can plot two curves on one set of axes if you use square brackets and separate them with a comma. Okay. Yeah, why do you do two different brackets? Great question, Maximilian. So what the outer brackets are doing, that's what the plot command is acting on. And this inside is like a little list of two things, which are traditionally enclosed by square brackets. Okay. Over here, I've only got really one thing. So no square brackets there, right? So this one tells you I want to solve this equation with respect to x. Okay, does that make a bit of sense, Maximilian? Let me know in the chat. Yeah. So this is a list. Basically, you've got more than one thing, and the round brackets are for the command, right? The plot command. All right. Okay. Let's go back to yes, Hong. Yes, that is absolutely correct. I mean, you probably could use square brackets. It probably would still work, but you don't need to do it. Okay. What range of values will x squared plus 4 take if x is between -3, -2 and +3? Okay. So you could do this by hand, of course, but let's do it in Maple and see what happens. Okay, so we've got x squared plus 4, and we want to plot it between -2 and +3. So I'll go back to Maple and I can show you how it works. Okay, so I'm going to go plot x squared plus 4, I think. Yep. X squared plus 4. And I'm going to restrict the domain between -2 dot dot and +3. Okay, so I'm telling Maple there that I want them to plot the graph of the function x squared plus 2 for the domain x between -2 and +3. All right, so let's do that. It gives us exactly what we want. And we can just look off the graph. Well, you're going to have -4 there, looks like 13 there, and a minimum of 0 there. Okay, so who can tell me in the chat, what are the range? Yeah, Aaron, the range of values is going to be between 0 to +13. Okay, and they're square brackets because the graph actually goes through those points. Okay, it achieves both a value of 0 and a value of 13. Okay, so a couple of commands: plot, solve. What else have we got here? Oh, I've done a plot 3D up here, so you can also plot in 3 dimensions, like surfaces and stuff, right? So you can, move that around and see what's happening there. So there I've plotted 2 different functions on the one set of axes. So probably I guess the most important ones are the plot and the solve commands for today's tutorial. What's going on over here? Yeah, and isn't that cool that you can solve inequalities? That's really, really good. Yeah, smart plot. You can plot implicit or relations type results. Okay. All right. We've got a few more minutes. Why don't we, if you guys want to open up the microphones, ask me questions about the course or anything really, feel free to turn your mics on and just say hello. Vrudant, great question. You can use Maple in the final exam, okay? You don't need a graphing calculator. You have got Maple, okay? So Maple's so powerful. Yeah, you can get Maple from the link that I put in the chat. Okay, so if you look back, Kankanam, I put the link in the chat. Let me see if I can find it. Where is it? There. Oh no, that's not it. I'm just looking for it now. Yeah. There it is. So you can put it in. You can go here, and it will. You'll be able. It's free, right? You just need a VPN. Okay. All right. So a few questions coming in. The assignment, the writing assignment. That's a really good question, Akif. It's the key with the writing assignment is to make sure that you are very careful with the punctuation and the layout and no typographical errors, stuff like that. More details will be released, but that's where people make the most mistakes. All right. So, Jade, are there any tests where we're not allowed to use Maple or a calculator? Lab test 2, a lab test 2 uses Maple. Lab test 1 don't need to use Maple. Okay. But you can use it if you want to. All right. In the final exam, yeah, you've got Maple, so you should just use that. I wouldn't rely on anything else. But yeah, you should be able to see that in the course outline. Let me look that up and I'll see if I can get back to you. Okay. William, do live lectures and pre-recorded lectures cover the same content? Yeah, it's almost the same. It's not exactly, but it's almost the same. Okay, so if you want to watch the pre-recorded stuff, feel free. If you want to come to the live lectures, great. If you want to watch the recordings of the live lectures, no problem. Okay. All right, Hong, what is the difference between balanced, deep understanding and solid foundation? So basic, intermediate, advanced. That's it. But my advice is just to try a few and see what works for you. Okay. That's fine. Snea, I would, what most students do is they want to, they realize that the Mobius questions are linked with assessment, okay? And so that's their first focus because there's assessment item every week. But the final exam is more linked with the course pack questions, the ones, some of the ones that we've done today. So what a lot of students do is they concentrate on the Mobius every week, and that's their first priority, and then they do the other questions. Tom, VPN, you just need something like, what is it? Let me just see. The university gives it to you. Let me see if I can find it. I'm just going to close my windows and I'll see what I can do. Just give me a second. Oh yeah, Citrix. So what I mean is Citrix. Maybe VPN's not correct. Okay. So yeah. So I think that's what they do. Okay, Dan Ling, the 40% online tutorial marks. Are you sure it's that much? I think it's 15% for two, like lab test 1 is 15%, I think. Lab test 2 is 15%, right? The writing assignment and then the let me just check that because I want to make sure that's proper, that the percentages are there. Hang on. Course pack. I'm just looking something up, so just give me a second. When I taught this course last year, the lab tests were 30% combined, and then the Mobius tests were worth. Yeah. Here. Let me show you there. Let me just show you. Yeah. Can you see here? Mobius lessons 10%. Lab test, there are 2 of them. They're 15% each. The writing assignment is 10%. And then the final exam is 50. Okay? Yeah. Oh, Jade, I wouldn't worry if you miss a tutorial. Don't worry about it. No one's keeping score or doing anything like that. Yeah, I mean, it's up to you if you want to come. Really, in my opinion. So I would not stress about that. Keith, in past terms, usually the writing assignment has been released in week 5 or week 6. So just wait for it. It'll come out in week 5 or week 6. Okay. So I think, oh, Theo, a question about limits. Oh, so Theo, it depends what the graph of the function's doing, right? So sometimes graphs will just increase and go off to infinity. Other times they'll wave up and down very violently and neither go to positive infinity or negative infinity. Okay, so that would be an undefined limit. So it's all about, what's happening to the function. Is it just sort of going off in one direction, or is it violently oscillating or doing something else? So yeah, so hopefully you didn't if you can put the question in the chat, Theo, then the function, then we can have it. But yeah, you definitely do not want to confuse infinite limit with a limit that's not defined, and that's quite subtle. All right, I think that's it. Okay, everyone, I'm going to say goodbye. Enjoy the day, and thanks for coming.
Thank you.
Thank you.
Thank you.
Good luck, everyone.
Yes.
And if anybody has any music requests, just let me know next week. Okay?
Thank you.
Play Fever the Ghost source.
Okay, give me the link if you can. If there's a link or something, just
I'll
post
link it.
Yeah, that would be great. All right, I'm out of here then. See ya.
Yeah.
Awesome. Got it, Aaron.